Greetings everyone, my name is Ziad Rajdi and I'm going to present my study that conducted under supervision of Dr. Tariq Jannat. The subject of this study is data-driven approaches to artificial lift system optimization using advanced machine learning techniques. The outline of the presentation we'll start with the introduction, introducing the artificial lift system and the machine learning. Then we'll go through the case study. After that, we'll have time on analysis and discussion, and finally we'll sum up that with the conclusion. Artificial lift system is a method used in oil industry to lower the bottom hole pressure and lift fluid to the surface. We use those artificial lift system when the reservoir pressure depleted and cannot reach to the surface. There are many types of artificial lift system in the world, but the common types are the sucker rod pumping system, progressive cavity pump, and electrical submersible pump and gas lift. Those pictures show three lift type and how they look like, which we have a surface unit at the surface and the downhole unit at the downhole for three lift systems. A machine learning is an area of artificial intelligence that focuses on development of algorithm and some statistical models allow the computer to learn from and make prediction based on the data. This machine learning method applied to improve the selection of artificial lift system in our study and have a strong look back into the historical data. The common types are supervised and unsupervised. The supervised, the trained data labeled with the appropriate output labels, while the unsupervised, the trained data unlabeled and the output also are unlabeled. And the flowchart here show those type. We have supervised learning since we have a labeled output, and our type is to have specific lift system, so we choose the classification type. Our case study, we gathered the data from three main sources. It's a very huge data from 995 producers. 105 wells are removed from this data because they have like instability, and we end up with 890 well for the study. We have almost 36 features, 27 of them eliminated, and we remain with the 9 common features to predict the 4 labels, which is the beam lift, PCP lift, standard ESP lift, and high temp ESP lift. And this is the distribution numbers of the labels. We split our data into 70-30 train test ratio, and this ratio is the common ratio used. Those are the 9 features with their minimum and maximum and average numbers. Those features, 9 features selected, has been run into test of a feature selection. We mainly use the filter method with the 2 types called chi-score and ANOVA test. And to confirm that those features are appropriate, we run those tests looking into a significance number called alpha, which is 0.05. From the analysis we done with the chi-score test, we saw that all of these features showing less than 0.05 significance number. Similar to ANOVA test, most of them show below 0.05 except 2 features, which is oil production rate and the wellhead pressure. From this test and analysis, we have confirmed that we are going to run our models based on these 9 features. Then we have built up the algorithms, 4 algorithms: decision tree, k-nearest neighbor, random forest and support vector machine models, and After we run those models, test them, we have those numbers. As a training accuracy, we can see that most of them above 90, except SVM. This is like below 95. The test accuracy also above 95 except SVM. In here, we need to improve the support vector machine model by hyperparameter fine tuning to improve its accuracy. What is hyperparameter fine tuning? It's a process where the parameter adjusted to find the best of it. And here we have three techniques. We have used those techniques and we end up that after applying those techniques with the hyperparameter fine tuning, we end up having a training accuracy of 97 and test accuracy of 97, which is a good improvement of 4.4% improvement. After that, when we confirm with the test and train accuracies that are very high, we start deployment of these models. So after the deployment, we show that all the models in the beam lift and PCP lift have a very high percentage, and also the standard ESP lift all are above 90% except the high temp ESP lift still they are good, only one which is random forest showing above 90, and this distribution you can see shown on those four graphs. For those 105 wells eliminated from the study, we picked 3 wells. Those 3 wells, call them Z1, Z2 and Z3 with those parameters, and the current production method is beam lift and standard ESP. We run those 3 wells to our model to check why they are unstable, and we cannot run those current artificial lift, and what are the models suggesting to run them in appropriate way. After running the test for this well Z1, all the models agreed with the current lift method. For the well Z2, there are some models have a deviation from the current lift method, which is the decision tree and the random forest. For the well Z3, which is currently running with standard ESP, 3 models suggest it has to be an high temp ESP, while SVM model suggesting it's a beam pump. Another task applied on 4 lift types, different lift types, for the wells that are highly performed and stabilized for many years. So we don't have any issue or problem with the current lift system. So the production method is beam for the well Z4, well Z5 is PCP, well Z6 is standard ESP, and well Z7 is high temp ESP. When we run them on the model, all the models agreed almost with the current lift system. So we have beam for the well Z4, PCP for Z5 similar to what current method, well Z6, 3 of them suggest standard ESP except SVM, and well Z7 also suggesting high temp ESP except SVM. From this we can conclude that we can rely on these models to help the engineers and the specialists to decide on the lift type. As a conclusion, the aim of the study was to develop machine learning that can predict the lift type in oil well. 4 algorithms were selected to this study, and those models show very good result in accuracies, which is above 95%. One model goes to the hyperparameter fine tuning to increase its accuracy, which is SVM, and we were success on that. We reached a 97% accuracy. All the models validated then using three ways, which is called cross-validation, classification reports, and confusion matrix. Those are the reference of the study, and that's it. Thank you very much.